mass is equal to 0.88 kilogram, and if we convert it into the gram, we multiply it by 1 kilo is 1 kilo is 10 raised to power 3, so we multiply it by 10 raised to power 3 and we get 880 grams. Okay, now 1 mole is 44 gram. So how many moles are there? So number of moles is equal to mass, that is at 880 gram, divide mass in gram divided by molar mass, which is 44. So this is molar mass. Number of moles, just write it down with your formula in your formula sheet. Number of moles small n is equal to mass in grams divided by molar mass. Okay, so this will be equal to 20. So we have 20 moles of gas. So at what temperature can we heat maximum temperature, after which because it can only withstand 2.3 into 10 raised to power 5. So at what temperature it can withstand? We already know the pressure. Now we need to find the temperature that this container can withstand the pressure of gas. If you increase the temperature, the pressure will increase, and if you increase the pressure temperature, pressure will increase, and it will burst. It will be it won't withstand that pressure. So what we need to do is PV is equal to nRT, and T is equal to PV divided by nR, and we will use the maximum pressure it can withstand. At this temperature it could work. When the pressure is this, at this temperature it could withstand. Otherwise, if you raise the temperature further above, pressure will increase and it won't withstand the pressure. Okay, so pressure is 2.3 into 10 raised to power 5. Volume is, we got volume somewhere, yeah, here, 0.39, and we got number of moles, we already did 20, and we got R, which is 8.31. So can you do this? 540 kelvins. So if you raise the temperature even 1 degree above 540, the container will not withstand the pressure. Okay.